Welcome, everyone. We're at RSA Conference 2019 with Satya Gupta, the founder and CTO of RSAC. Satya, welcome.
Thank you very much.
It's nice to have you here. It's nice to talk about some of the advanced defensive things that we can do on systems today. There's obviously a lot of technology out here today, but I love the advanced defensive software that is protecting from the advanced threats, which, correct me if I'm wrong, did I summarize that correctly of what your product does?
Absolutely, you did, absolutely.
Good. So how did you found the company, and what problems were you trying to solve early on?
So back in 2007-ish kind of time frame, there was this slammer worm.
Yeah.
It was striking every hour, was pulling down like about millions of PCs and all. And we were seeing the antivirus companies were putting out signature after signature. Every 10 minutes there was a signature being updated.
Mm-hmm.
And so, I'm thinking to myself, this is really a frustrating experience, and I was friends with another professor at University of Massachusetts. I was sitting with him in Starbucks, and we ended up discussing this issue, and we realized that, there are better, smarter ways of doing this, using some really fundamental rules of computer architecture. And that's where the company got founded. And, the main thought behind the company was to follow the control flow of an application and make sure, the application is always executing the developer's intent rather than, the bad actor's intent.
And I think it's so well said, right? And so many products and techniques try and do that. But I think at the end of the day, if you simplify it down to that level, what the developer intended and how an attacker uses software that's running on the system are two completely fundamentally different things most of the time, at least at some juncture, right?
Absolutely.
And that's what you're monitoring on the
Absolutely.
On the systems.
When the developer, many developers will write pieces of code that potentially are vulnerable and they can be hijacked. But for the most part, most users will not exercise the application in such a way. But then it's possible to for a bad actor who's not as well intended as a regular user, they could provide the application some really nasty input that would drive the application off the edges of the guardrails that it wants to be able to run on.
Right.
So we figured that, if we can actually, at that point, when the application is run off its guardrails, it starts executing what the bad actor wants it to do.
Right.
So it's like, if you were sitting in a car driving down using your navigation system, some bad guy gets in your car, holds a gun to your head, makes you drive off to somewhere you didn't intend.
It's a great analogy. That's exactly what we do as attackers, right?
Exactly.
Yeah. And so now, when the product is installed on the system, is it you monitoring specific applications, or is it monitoring all applications? Like, this isn't just an application-specific thing.
Right.
It's an operating system protection of all the apps, correct?
That's a great question. We have capabilities that transcend, there are very host specific, so they'll work on every process. But we also have capabilities that you can choose, this high value process that's performing, my application's business logic is being executed in this process. You can choose to monitor it even more tightly than the rest of the processes that you are running on the system. So in that sense, we can actually insert our probes, basically sensors, insert themselves into those processes that you selected, and you could select all of them. I mean, there's no reason to not do, any particular process that you would like to do. You could actually use that particular process there. And especially in the world of containers, where, container runs a specific process, this is an ideal fit for them. So we have host-based solutions, we have process-based solutions, we have file-based solutions, and as processes are starting up, we have application control capabilities in the product. We can even protect against attacks like side channel attacks that have been known to take, have been targeting speculative execution capabilities that have recently become a problem.
That's awesome, yeah, because that deviates enough off the rails where you would detect that. But now in a container environment, if I have a container and I put I have a Python application, it lives inside of a container, I could use RSAC to put rules and safeguards around that application, deploy that container wherever I want, serverless, in my data center or someone else's data center, doesn't matter, correct?
Totally, exactly right.
That's really awesome.
Yes.
I want it.
Yes.
These are always great conversations and good validity where I hear what it does and I'm like, I need that. I need that in my life to protect my containers, right? Because containers are going to go everywhere now, and I don't have those operating system or lower layer controls anymore.
Exactly. And the big thing about protecting processes or the memory in which the process is executing is that you have extreme visibility. If you look at all the other solutions like firewalls or web application firewalls that are kind of sniffing at the input traffic that's coming in, they're completely devoid of any context, and they don't really care what the application is going to do, how the application is going to respond. But that's really, really important, because the battleground is the process memory. That's
absolutely
where you and I are talking, but it's like those people outside on the street. They're trying to figure out what's going on. They have no shot at it. But anybody who's in this vicinity who can hear everything that we are talking about will be able to do a much better job and analyzing what's being said out here.
Right.
So,
is it, when it's protecting my application, is it detection and prevention, and how is that balanced?
Absolutely, we do have the way it works is that there are some attacks that are single stage attacks, which means like a SQL, for instance, right? Attack, if we let it through, then it'll go and change something in the database. So we kind of preemptively block it at the entrance level. But there are some other attacks like a buffer error where somebody would break into the solution, and then they'd actually establish a sort of a remote command control connection to their command control servers. So they're multi-stage kind of attacks like that. So we'd actually be able to terminate them within milliseconds. All these attacks would be terminated anyway. So and we publish very high quality metadata about these attacks into what we call our protection engine. The protection engine is completely configurable. You can have a callback that basically can either send an email, do benign things like send you an email or send you a text message, but can also go move your VM from your regular militarized zone to a quarantine area.
So you have integrations into the virtual layer as well. Yeah.
So we call those micro actions, which basically affect the application that are under attack. But we can also take what we call macro actions. So we can go take because we have very rich context, we have IP addresses of users and all. So we could take that information and feed it back into the router and blacklist a user or create. The
telemetry from the attack can be integrated into other protection mechanisms, in addition to protection inside the processes themselves.
Yeah, so micro actions protect the application that is coming under attack, and macro actions kind of work on the peripheral infrastructure that's around the application.
Right. Now, what if I have an old application? And I know that it's going to, and so many people are in this situation, right? You've got an application, it's been around for years. To rewrite it is 6 months to a year or plus.
Totally.
But in that meantime, I still have to use it.
Absolutely.
And RSAC is a very good application for this, correct?
Totally non-invasive. We don't need source code. We actually bolt on, and there's a big bank in New York that says it's a bolt-on security with built-in efficacy capabilities.
Yeah, no, that's yes. Hearing about it, that's a very good description.
Exactly.
Yeah, absolutely. So, how do you know what is good behavior? Do you profile the application first, or do you have like a database of profiles of ways certain applications should work? Like, how do you separate good from bad, essentially?
Okay, so that's a really great question. What we do is we are not monitoring the data; we are monitoring the code. And code is inflexible. You'll have, if you take a calculator and you punch in 2 + 2 in it, it'll be, the answer is 4 today. It'll be 4 5 years from now, 15 years.
Right.
And it never changes. But the data can keep changing. I could add 2 + 3. I could punch in 2 times 16 kind of thing. So what we monitor is the code. The code is, is inflexible in the sense that, we'll actually execute, if there's a function foo that's meant to call function bar, it'll always, theoretically, it should always call function from foo to bar, never function foo bar, which might not be part of the source code. So as soon as
computers work in binary, right? Like what's in the code is in the code.
Exactly.
Yeah. No, you don't need the source code to.
We don't.
You're looking at the binary,
Right.
understanding the functions,
Right.
and then noting deviations from
Exactly.
what it should be doing.
Exactly. If you think about it, if I were to give you a piece of source code, you'd be able to follow the logic and, if function
Most
is
of
allowed
the
to
time,
run. Yes.
depending on the developer, right?
Exactly.
Sometimes I can't understand my own code.
But in many ways, if you think about it, the application gets compiled, linked, and built, and all that. The sources of truth, the logic is still the same. It's just that it's turned into machine code that's not easily readable by humans. But this is where our speciality is. We can actually read that binary and extract all the information back from the binaries, and we are able to follow the logic of the developer.
That's fantastic. Any new features that you're announcing at RSA?
Yeah, absolutely. We had actually three great capabilities that we are now announcing. There's application control, which means we have this very nice way of whitelisting, which is completely it's refreshingly different from how people do application control or whitelisting. It's a completely hands-off strategy. And then we also have a very nice file signature repository system that is built using your own capabilities. You don't have to go out to these third-party tools and verify signatures at all these obscure places. It also tracks scripts. So the big difference with many other file monitoring systems is they don't track scripts. And you hear about these fileless attacks and all that could have been prevented if we were able to track scripts, but we don't. So we feel that there's these three categories of attacks that we like to think about. File-based attacks, which is basically the bad actor is sending you an exe or an executable file.
Yep.
A fileless attack where the bad actor is typically sending you maybe something like a PowerShell script or something.
Yep.
Those are relatively easy things to quench. But then the bigger trouble comes from these, what many people in the industry are now beginning to call weaponized at runtime attacks, where the application, a genuine application, accepts badly crafted data and turns on itself.
Right.
So those are really hard to detect because all the action, there is no file, no executable, no script, nothing out there, and yet the application is turned on itself. So these are truly the memory attacks that are the future. And things like side channel attacks where I can steal data from an adjacent process without ever attacking it. I could extract RSA keys or all kinds of secrets and all. So those are the new generation attacks that we feel are going to be, top of the mind in the next few years. And we feel that, the industry is really needs to catch up and people really need to think a little bit more about what's happening in memory. That is the key for future.
All of the attacks that I see that I really like and believe will be effective for pen testers, right, are definitely all in memory.
Exactly.
Attacks.
And there's good reason there.
They go through great lengths to make sure that it's all in memory.
Exactly.
That's really cool.
And in the memory there is all these very high quality signals that are available. You can see immediately, just like if you're using a GPS, you'd know right away if you deviate from your path. In memory, you can actually, with things like control flow technology that we use, we can actually see that right away within microseconds that you are not executing your developer's intent and you're serving an attacker's intent. Those are very explicit signals that you can see in memory that you don't see in the network or post detection or EDR tools and machine learning and all will underserve you essentially in those cases.
So your solution, just in case our audience is wondering now, right, is an agent-based system, Windows and Linux support?
Yes.
With a control in the cloud or on-premise, I'm
No,
assuming?
control is in your own, wherever your network is, in your own data center.
Yep.
Yes.
Okay.
It's in the same location. If it's the prem, then it's in the prem. Or if it's in the cloud, then our analysis happens in the cloud. It's in your control.
Okay, so I put it wherever I want.
Wherever
essentially.
you want. Exactly.
Yeah. That's awesome. That's awesome. And I like the Linux inside of the container.
Yes.
Great solution for that.
Right.
because so many attacks now and so many people are deploying containers. So that's a great deployment model as well.
Absolutely.
And you can just build that right into the container at runtime in your CI/CD process, and it goes in every single container I deploy.
So it's a very important point that you raised, because the infrastructure is completely software driven. You don't know where what is anymore. The network is very loosely defined and all. So the important point is that the security control is right with the
application,
with the workload itself.
Yeah.
So it's it's kind of bound together.
Yes.
Inseparable. So
it's hitting on my theme, Satya, that security has really been pushed to the application and down to the user side. Like everything in the middle now is becoming more and more just like foundation and plumbing, right?
Exactly.
And this is why solutions such as yours, I think, are so critical today. It's going to be inside or on the same workload, as you say, of my application. It follows it wherever it goes.
Exactly.
That's awesome. Satya, thank you so much.
Thank you very much for taking it.